Hello, I am Sunil Divekar. We'll try to solve a problem on how to calculate the number of vacancies per meter cube for a given crystal. I am referring to this book, which is Callistra's Material Science and Engineering, second edition. It is by obviously Dr. William Callister and David Ritzworth. And in this book, the numerical that we are going to refer to is this particular numerical 5.2. This numerical on page 5.2, numerical 5.2 on page 141 reads like this. We have, says, calculate the number of vacancies per cubic meter in gold at 900 degrees Celsius. The energy for vacancy formation is 0.98 electron volt per atom. Furthermore, the density and atomic weight for AU is gold. So density and atomic weight for gold are 18.63 grams per centimeter cube, which is at 900 degrees Celsius, and 196.9 gram per mole respectively. Now while solving these numericals, we are going to refer to equations given in this particular book and also the values of certain constants. So if we focus on the page 112 here, in this page 112 of the second edition, the value of Boltzmann constant, for example, is given. Its value is given to be 1.38 into 10 raised to minus 23, but this value is correct if the units are joules per atom Kelvin. Now in our numerical, since the value for the energy is given in terms of electron volt per atom Kelvin, we are going to refer to 8.62 into 10 raised to minus 5 as the value of the constant. So let's solve this numerical. As mentioned in the question, we will have certain data, the value of which it is given. So for example, in this case, when they talk about a temperature, the temperature here is 900 degrees Celsius. So we have 900 degrees Celsius, but we have to remember that this numerical requires the use of temperature in Kelvin, which means we have to add 273 so as to obtain the value here as 1173 Kelvin. Now the energy required for the formation of vacancy QV in this case is given to be 0.98 electron volt per atom. The density is given here as 18.63. So it is 18.63 and the units are grams per centimeter cube. Also, the atomic weight of gold here is given as 196.9 gram per mole. So it is 196.9 grams per mole. The Avogadro's number is a constant. This is 6.23 into 10 raised to 23. And its units will be in atoms per mole. The Boltzmann constant in this case is given to be 8.62 into 10 raised to minus 5 as mentioned in the book, atom Kelvin. Now these two values, the assumptions, you will have to find from the book if it is an open book examination, or you'll have to memorize them if it is a closed book examination. And then in this question, we have to find out the vacancies per meter cube. Now to find out the vacancies per meter cube, we first need to know that in a given crystal of gold of size 1 meter cube, how many atoms can fit in. Now to calculate that, the equation that is used is the number of sites in this case is equal to the Avogadro's number into density upon the atomic weight of the gold, that is AU. Now this is given as, so it is 6.023 into 10 raised to 23. This is going to be in grams per mole. This value is Na. It is to be multiplied by density. So the density is given to be 18.63. So we have here a density of 18.63 and this value is in grams per centimeter cube, right? This is atoms per mole, not grams. Now, if we take a look at this, we will have some answers in centimeter cube. So you have to convert this centimeter cube into meter cube. So that is 10 raised to 6 centimeter cube per meter cube. Now this divided by the AAU in this case is 196.9 grams per mole. So when you do the calculation here, we will have the values. What is it? So we have 6.023, 6.023 into, since it is 10 raised to, we have to press this shift and the yellow color 10 raised to x. So in this case this works out to 23. This value multiplied by 18.63 and this value multiplied by 10 raised to 6 and divide this by the answer by 196.9. So this is divided by 196.9. That gives you a value of 5. This gives you a value of 5.698 into 10 raised to 28. Now this, the units of this, please remember when we talk about the number of sites, so it is going to be atoms per meter cube. Now to find the vacancies, we need to make use of the equation again given in the textbook. This equation is NV, which is the vacancies that we have to find out, is equal to n exponential raised to, so it's minus QV divided by KT. So minus QV is already given here. This is 0.98. So when we substitute the values, this becomes the 5.698 into 10 raised to 28 e raised to, it will be minus 0.98 divided by 8.62 into 10 raised to minus 5 into 1173. So this is the temperature and this is the constant K. The temperature here is 1173 and the constant K is 8.62 into 10 raised to minus 5. That is what we have seen. So when we try to calculate that, we'll have here, now this value is already there, and then we try to multiply this by, since we have to take e raised to x here, this is the key that we need to operate, e raised to x, it is in yellow as you can see. To activate that I have to press this key, which is shift. So activating this, we'll have shift and then we have e raised to x, and then inside this, so e raised to x, we have to open brackets. So I'm opening brackets. There's a value of minus 0.98, bracket complete. Now this value is divided by, again open a bracket, it is 8.62 into 10 raised to minus 5 here, right, bracket complete, and multiplied by again 1173, all that closed in a bracket, and that's going to be giving you 3.519 into 10 raised to 24. As you can see, this is 3.519, and this is 10 raised to 24. So the answer here is going to be, I'll round it off to the 3.519, I'll round it off to 3.52, and therefore this is going to be 3.52 into 10 raised to 24, and these are vacancies or vacant site per meter cube. This is the answer. Thank you.